Hello, and I hope you're fine as a student, or maybe a teacher is here listening to me. I hope you're fine, and today I just decided to do trigonometry 1. Trigonometry 1. So in trigonometry 1, this is the subject or a topic that we cover in Form 2 work. So in Form 2, we just introducing to the learner or to the student what is trigonometry. And when we talk about trigonometry, in Form 2, we will handle something we call it trigonometry ratios. Trigonometry ratios. From the word ratio, we can say that it deals with the relationship. It deals with the relationship between sizes of the size of one angle and the length of two sides in a right angled triangle. Okay, so trigonometry ratios in Form 2, we say that it deals with the relationship between size of one angle and the length of two sides in a right angle triangle. So guys, I know most of you know a right angle triangle. A right angle triangle looks like this, and mathematics is very simple. So if a right angle looks like this, a right angle triangle, actually it is a triangle. So if it is a right angle triangle, a triangle has three angles. From the word tri means three. So if it has three sides, that means that we have the first angle, the second angle, and the third angle. But remember, trigonometry ratios, we have been told it deals with the relationship between size of one angle. For example, let's focus to this angle, call it theta. This sign, it is called theta. So if we label this angle theta, so if we are focusing to this angle theta, we are comparing this side, or maybe this side. Either of them, we have the first side, the second side, and the third side. So we call this one sides. These are sides and these ones are angles. So trigonometry ratio deals with the relationship between size of one angle and the length of two sides in a right angle triangle. So I hope you have understood the first part. We have said the trigonometry ratios deals with the relationship between the size of one angle and the length of two sides in a right angle triangle. Okay, so now the second thing, we now introduce you to the tangents, cosines, and what we call the sine. So we will start with the tangent of an angle. So the first one is the tangent of an angle. So when we talk about tangent of an angle, so if I draw this, the same triangle that we had in the first place, so we call this the first side, second side, and then the third side. And then this angle, we label it as the angle theta. Okay, so we label this one as angle theta. So if I have these sides, this one, if this angle is here, okay, if this angle is here, so what does this mean? It means that the angle, the side that is just immediately, or what can I say, we call it adjacent, this side. And then this side, because it is opposite the angle theta, we call it the opposite side. Okay, and this one, this longest side, I know most of you know it, we call it hypotenuse. Hypotenuse. So this one we have been learning since primary, and I hope you understand that one. And then so I don't know if again I have this angle. For example, if my theta is here, if this angle is theta, what do we call this one? So this one is theta, this one is the opposite. Now the sides change. The only side that doesn't change, mark that one, it is hypotenuse. The side of hypotenuse does not change, but the adjacent and opposite can change depending on where you have named your theta. If it is in this side we call it the adjacent, this one opposite. But when the angle is here, we call this side opposite, and then adjacent will be here. I hope you understand. Okay, if you have any question, please go to the comment section. I'll be seeing at the comment, and also as you comment, like the video, and also subscribe to the channel. So I want us to go to the relationships now. The relationship between these sides, between these three sides, you have the opposite, adjacent, and hypotenuse. So for a tangent of an angle, if I want to find the tangent of angle theta, I will say it is opposite over adjacent. Opposite over adjacent. Okay, when you are told to calculate the angle theta, you take opposite over adjacent. Okay, and then if I tell you to calculate the cosine of angle theta, the cosine of angle theta, we get it by taking the adjacent over hypotenuse, and then if I want the sine of angle theta, I'll take opposite over hypotenuse. So we have a small formula. I don't know the English people, what do we call this one? If I say I have for tan theta, it is opposite over adjacent, cosine is adjacent over hypotenuse, sine of angle theta is opposite over hypotenuse. I can shorten it to so katoa. So I know the English people will help us here in the comment section. Help me, what do we call this one? If you find a formula or a small thing to describe something, so for easy remembrance. So this one stands for sine theta. Sine we can shorten it as sin theta, which is opposite over the hypotenuse, and then we have the cosine, or we shorten it as the cos theta, which we have said it is the adjacent over the hypotenuse, and then we have tangent. Tangent we can shorten it as tan theta, which is opposite over adjacent. So that's the relationship, guys, between these three sides, the adjacent, the opposite, and the hypotenuse. We can get an angle, sine theta, cos theta, and tan theta using these example, using those relationships. So I want us to do an example to to just illustrate what we have done. For example, if I have this right angle triangle, this one, and then I'm given here 40 degrees, and then I have this length. Let's name this triangle as A, B, and C. So if I have at angle, so this one, the angle, I hope you know that one. This is the sign of an angle. So angle A, B, C is 40 degrees, and the length AB is 4 centimeter, and length CB or BC is we have 5 centimeter, and then the length AC we have 2 centimeter. So here is 2 centimeter, we have here 4 centimeter, and here is 5 centimeter. Of course, it is the longest side, so it should have at least a long or the bigger value. So we have this example. If I want you to find tan theta, what will you get? Sin theta, and then we have cos theta. What will you get? Of course I will get, if I want tan theta, we have said you write your English people, you will help us. You write your formula, SOHCAHTOA. So we are dealing with the tan here. This one, tan. So we have said tan is opposite over adjacent. So you come to your opposite. Your opposite is here, opposite angle. So tan theta will be opposite. Our opposite is here, which is 2, over adjacent, which is 4. Now you can find. But guys, remember, if we have this 40 degrees, let's not name here. Let's call it theta, because we are finding it theta. So if I use theta, you should not be given this angle, because this is the angle we are looking. So if I have theta, then I can now look for it, or I can calculate it. So we can say that tan theta is equals to 2 over 4. But remember, this one will give us a decimal number. And when you're dealing with the finding the tan theta, this is what you do, guys. You come and then you swap this one this side. You say tan, then you put here hyphen and then 1. It means tan inverse of 2 over 4 is equals to theta. I hope you get that one. Tan inverse of 2 over 4 is equals to theta. So if you go to your calculator and then you press, if you want to look for tan inverse of 2 over 4, you go to the shift button and then you come to tan. It will automatically show inverse, and then 2 over 4, you get theta. But because, guys, I don't want this video to be too long, so in our next video we are going to continue to give more examples and to illustrate more, so that you can understand how to find the tan inverse. And we will have another video to guide you on how to find tan inverse in your calculators. Just a guidance for those that are in Form 1, for those that are in grade 8. I know grade 8 you are using right now, you've started using the calculators, and so we will be doing all that illustration in our next video. Bye bye, see you next time.